Well, hello again and welcome to May. It's hard to believe that it was the middle of March when all of this started, but here we are with almost the end of the school year. We've got this week and then next week, and that's it for this whole school year. Before we get into the official notes this week, you might remember that right before all of this madness with the pandemic started, I had a problem that you guys were doing in class that talked about the southern lights or the aurora australis. And we talked about the probability that you could see those from an island in southern New Zealand. I was actually hoping to visit New Zealand this summer and had all kinds of arrangements made to do that trip. And honestly, to no one's surprise, I found out that New Zealand has not only closed the border now, but it's looking like they won't allow visitors until at least the beginning of 2021. So I will not be heading there this summer, which I'm kind of sad about, but hopefully it'll make for an even better trip sometime in the future. Well, this week we're going to look at the last section of Chapter 0, that section that reviews everything that they expect you to have learned so far before you go into calculus. And this section actually deals with some of the stuff we were doing back right at the time when the pandemic started. It's going to talk a lot about exponents. And I will tell you that compared to some of the other sections that we've done, this section should be easy. In fact, basically everything we're doing you should already know. I mentioned that, but you notice I've got a graphic that says caution on here too. That's because there's a lot of questions that can be kind of sneaky. And that's why I really do suggest that you go through this whole video before you worry about taking the quiz or doing the problems that go with it. So there's sort of a worksheet that I have that goes along with this. This actually is the problems from section 5 in this book. And something that's kind of important about these is the expectation is that you shouldn't use a calculator for these. I'm going to mention that sometimes when people do things like the placement test for Iowa Lakes or other things along that line, one of the things that kills them is they are used to using calculators for everything, and suddenly they get into a situation where they find it hard to do stuff without a calculator. Everything on here can be done perfectly easily without a calculator, and I'm going to try and point out what's up with those. Now, what I'm going to do in the film is we're going to go through about half of these problems. I'm going to go through the practice problems at the top, and we're going to go through like every other problem on the rest of it. Your assignment this week is to basically look through all the other problems. I would suggest that you take a look through them anyway, and I'd suggest you actually try and do the ones that look hard. And then go back and just kind of check the answers to everything. The easy ones you can probably do anyway. It's the harder ones you want to make sure that you do know how to do, not just because it'll make your quiz easier, but also because it really does make a lot of things easier that involve math later on. So the first two practice problems, one of them says -5 squared, and the other one says 16 to the 0.75 power. One thing, since this worksheet is a copy of a copy of a copy, things like that decimal exponent don't copy real well, but it is 16 to the 0.75 power. So I told you these are mostly easy, but there can sometimes be tricks. And the very first problem is one that sometimes people will screw up. The right answer is -25, because the important thing about that is you do order of operations. You square first, and then you make the answer negative. Sometimes people think, well, if you square things, it's always positive. That would be true if I had parentheses around the -5. But the way it's written here, yeah, you do 5 squared, and then you make it negative. Part B is reviewing a couple of important things. This is the same thing as 16 to the 3/4 power. When you've got a fractional exponent, the top number is a power, the bottom number is a root. The easiest way to do this problem is to think, what's the fourth root of 16, and realize they wouldn't have asked you the question unless it was something easy. That's 2, so now I've got to do 2 cubed, and I get 8. If I wanted to, I could have taken 16 cubed and then done the fourth root of that, but that becomes hard because it involves big numbers. I can do the fourth root of 16 is 2, 2 cubes 8. Number 2 on the practice problems has 3 parts. On part A, all you really need to remember here is that when you take a power to a power, you multiply the exponents. And that's why I would write 4 to the 6th as an answer. Now, theoretically, you could write a number there, but again, our goal is to think, what would you do without a calculator? And 4 to the 6th is pretty much what it's going to be. On part B, again, if I have a root, that's the same as a fractional exponent. Notice I wrote x to the 1/3 power. On the bottom, I just rewrote x cubed as x to the 9/3, and the reason I did that is I know that when I have division or a fraction, I subtract exponents. And what I wrote down for an answer here was x to the negative 8/3. Now you could also write that as 1 over x to the 8/3 power. That would be okay too, but there's nothing that tells me I have to do it that way, so I just leave it as x to the negative 8/3. And here's part C. The directions just said simplify. And when you've got big polynomials like the bottom of that fraction, it's never a dumb thing to think, can I factor this? And it does turn out that x squared plus 10x plus 25, that would be x plus 5 times x plus 5, or x plus 5 squared. Then what I can do is take that x plus 5 squared on the bottom. It's going to cancel out 2 of the factors of x plus 5 on top. And that's why my final answer is just 2 times x plus 5 squared. So I'm going to go through like every other problem on the main part. Number 2, negative 2 to the 3rd power is negative 8. And on number 4, 0 to any power at all is always going to be 0. Number 6, you have 100 to the 4th power. And I know everybody, their first instinct would be to haul out the calculator and literally take 100 to the 4th power. But you really don't have to do that at all, because 100 is just 10 squared. And if I take that to the 4th power, what I've got to do is multiply exponents. That's going to give me 10 to the 8th. 10 to the 8th is a perfectly good answer. You could just leave it that way. Or you could realize that all that means is you're going to have 8 zeros at the end, and that's why the answer is going to be 100 million. And you can do kind of the same thing on number 8. 0.01 is 10 to the negative 2nd power. If I take that to the 3rd, I need to multiply exponents, and my answer is going to be 10 to the negative 6. Well, a negative exponent, what that means is that we'll have 5 zeros, and then the 1 will be the 6th place after the decimal. So 0.000001. 10 and 12 both say the 1/3 power, which is the same thing as cube root. Cube root of 27 is 3. Something that people don't always realize is that when you have a fraction and you're trying to do a power or a root of it, all you have to do is take the cube root of 1 on top and the cube root of 125 on the bottom. That's why the answer is 1/5. Negative exponents mean you flip things over and do the reciprocal. So 1/2 to the negative 1 power would be 2 over 1, or just 2. Negative 5 to the negative 1 power is going to be 1 over negative 5, or negative 1/5. Sometimes I'll have people on number 16 there that think that the answer should be positive, but those negatives don't cancel. The negative 1 power just means you flip it over. Number 18, we've got the 3/4 power. Again, the top of that is a power, the bottom's a root. So just like on that sample problem earlier, what I've got to do is take the 4th root of 16 and then cube that. That's 2 cubed, which is 8. And on 20, I would do the cube root of 27 is 3. 3 squared gives me 9. Again, it's kind of hard to read the decimal exponents on here, but it is just saying 9 to the 1.5 power and then 81 to the 0.75 power. Well, that's just the same thing as the 3/2 power and the 3/4 power. And again, the top number is a power, the bottom number is a root. What I did with this one is I took the square root of 9 and then I cubed that, so 3 cubed is 27. And then I did the fourth root of 81, which is also 3. And if you cube that, you're going to end up getting 27 again. Again, a negative exponent means I flip this over. And after you flip it over, you end up with a positive exponent. So this is the same thing as 8 to the 2/3 power. Cube root of 8 is 2, square that, you got 4. Now there's lots of ways you could make number 28 hard, but the way you make it easy is you realize that 1 to absolutely any power at all is always 1. And that's all you do. Number 30 is one that kind of looks intimidating, although it turns out to not be all that hard of a problem. Big thing that comes up on number 30 is I've got 3 to 1 power times 3 to another power, all raised to the 6th power. And you notice what I'm doing here is I split this up into two problems. I first of all took 3 to the 1/3 to the 6th, and then 3 to the 1/6 to the 6th. And each of those times, what I'm doing is I'm multiplying exponents. A third times 6 is 2, a 6 times 6 is 1. So I really have 3 squared times 3 to the first. I could either just think of that as 9 times 3, which is 27, or I could add up the exponents and figure out this is 3 to the third, which is also 27. Again, when you take a power to a power, you multiply the exponents. So here I've got to multiply 4/5 times 5/8. The 5's cancel, and we get 4/8 or a half. 9 to the 1/2, that means the square root of 9, so it's 3. When you divide, you subtract exponents. 5/2 minus 1/2 would be 4/2. That's why this is 3 squared, or 9. So 36 is looking at another rule that you may not actually know ahead of time. It says 20 to the 0.5 times 5 to the 0.5, or that would be like the square root of 20 times the square root of 5. Now, nobody knows right off the top of their head what either the square root of 20 or the square root of 5 is. But when you got a problem like that, where they're both to the same power or the same root, what you can do is multiply the two bases together. And I know that 20 times 5 is 100. That's why this is really 100 to the 0.5, or the square root of 100, and that's easy. The answer is 10. 38 is almost the exact opposite of that. This time what I want to do is split this problem up into two cube root problems. The cube root of 125 would be 5. The cube root of 27 is 3. And if you take 5 times 3, the answer's got to be 15. 40, it says 0 power. Anything to the 0 power is going to be 1. Now starting with 42, you notice we don't have numbers for the bases anymore, we have variables. And this is much more likely to be what you'll see when you get to your quiz. The reason why is that if I did just put numbers, I know everybody would just type them into your calculator. With variables, you got to know the rules, and that's what's going on with 42 and 44. Again, on 42, I just multiply the exponents. A third times 6 is 2, so x squared. And the negative exponent means that you flip it over or move it to the other part of the fraction. This one's going to end up being x to the third power. 46 is a lot like that one that had 27 and 125 earlier. I just split it into two parts. I basically do 3 and a third, I multiply those and get x to the first, and then 6 times a third gives me y squared. And on 48, what's going to happen is I've got to flip both the x and y around, then I square them, that's why we get y squared over x squared. 50 is another of those things that looks harder than it really is. Here, what I did is I rewrote the first part as 1 plus x to the 1/2 power, because square root is the same as 1/2 power. Well, now I've got 1 plus x to two different powers, and they're multiplied together. That's why I just add the exponents. A half plus 3/2 gives me 4/2, which is 1 plus x squared. And I would just leave the answer like that. You could like FOIL out 1 plus x times 1 plus x, and it's not wrong. It just is, why would you make more work than you have to? So 1 plus x squared. Again, multiplication problems, you add the exponents. That's why I've got x to the 4th on 52. And on 54, I first of all just reduced the fraction -3/15. That's -1/5. And now I'm going to subtract exponents. And what I did here is I wrote 1 over 5x cubed. If you wanted to, you could write things like -1/5 x to the -3. That's not really wrong either. 56, the negative exponent means I've got to move the y up on top, so we get x cubed y squared. And when you've got this whole quantity to the 3rd power, I take -3 cubed and then x cubed. So -27 x cubed is my answer. If you're following along in the answer key that I had to go with this worksheet, I've got the answer to number 60 wrong. And I caught that when I was doing the recording for this video, actually. What I had done was 9x to the 1/2 power, but it really says -1/2. And that's why I've got to make this a reciprocal with most of the stuff on the bottom of the fraction. What I do then is I do the square root of 9 and the square root of x, so 1 over 3 square root of x. Again, fractions, we're going to subtract the exponents, and that's why I end up with x cubed on the bottom, so 1 over x cubed y. And then on number 64, because of the negative exponent, the x is going to move upstairs. We get x to the 5th over y. We've really got two separate problems on 66. When I multiply the exponents, 9 times 2/3 is 6, so y to the 6th is part of our answer. I've also got to do -8 to the 2/3 power. And again, that means I do the cube root, and I've got to square it. And when I do all of that, we're going to end up getting 4 y to the 6th. You could write out your answers on a lot of these in multiple ways. This time I actually wrote it two different ways. The coefficient in the answer is going to be 125. It's just the square root of 25 is 5, 5 cubed is 125. Then what I've got to do is work with all of my exponents. I've got x to the 3/2 on top, x squared, which is like 4/2 on the bottom. If I subtract those, we're going to be left with x to the 1/2 on the bottom. And that y to the 3/2 minus y, that's like 3/2 minus 1, that gives me y to the 1/2 on top. Now I could just leave the answer like I have at the top right, or I could realize that 1/2 power just means square root, and it's okay to write it either of those ways. Number 70 is actually another one that I noticed a mistake I'd made when I made up the answer key as I was recording this video. Here, what we're going to do for the coefficient is take the 5th root of -32, which is -2. If you cube that, you get -8. I forgot the negative in my original answer, but -8 is the coefficient for our answer. And again, the -3rd power on y means I'm going to get y cubed down on the bottom. So hopefully all the stuff up through about number 70 makes fairly decent sense. And I will tell you that most of what you're going to end up doing will involve that kind of problem. I'm going to take a look at numbers 72 and 74. Although I'm going to tell you the honest truth is that it's the least important part of this section. It's probably not really going to be on the quiz. It's mostly there to kind of make you think about how stuff goes together with math. So you notice this says 2x to the 2/3 minus x to the negative 1/3, and it tells you that equals x to the negative 1/3 times something, and we're supposed to figure out what that something is. This is a skill that does come up in advanced math, which is why it's here, but it's far from the most urgent thing even there. But I want you to ponder that for just a minute as I bumble around just saying nothing in particular, and see if you can think, how could you go about figuring out what you'd have to multiply by? And the important thing is to realize that when I'm trying to find what I multiply by, what I've got to do is divide. You could think of this as just an equation that says we've got something equals something times what we're trying to find. Well, the way I try and figure out what I'm trying to find is I divide both sides by what's next to it. So I divide by x to the negative 1/3 power. And the key thing is I've got to divide everything over on the left side there by x to the negative 1/3. So 2x to the 2/3 divided by x to the negative 1/3, and x to the negative 1/3 divided by x to the negative 1/3. Well, that last part's easy because anything over itself, even if it has like negative 1/3 power, anything over itself is always 1. So that's why I've got minus 1 at the end of my problem. The first part, I've got x to the 2/3 over x to the negative 1/3. And again, what I've got to do is subtract exponents. I take 2/3 minus negative 1/3. That's going to give me x to the 3/3 power, which is just the same as the first power. And you put that all together, that's why my answer is going to be 2x minus 1. And 74 is a similar type of thing. Again, I'm going to let you look at it for a minute and then we'll go through the answer. But again, don't get real upset if you have troubles with these two. And just like before, the key to this is to divide everything by what's out in front of the parentheses, divide by the square root of xy. Now, when you divide by something, you should remember from about 4th grade that that's the same as multiplying by the reciprocal. And if you look at what I actually have over on the right-hand side of this equal sign, I put the square root of x over y times 1 over square root of xy. And then I have minus the square root of y over x times 1 over the square root of xy. I'm just multiplying by the reciprocal of what's on the right there. And the trick to simplifying this is that we end up with some of the same stuff on the bottom of those fractions. If you look at the first part, I've got on the bottom square root of y, square root of x, square root of y. Well, y times y is y squared, and if you have the square root of y squared, that's just plain y. What's more, in that first fraction, square root of x over square root of x just cancels down. That's why the first part of my answer ends up being 1 over y. Pretty much the same kind of thing happens on the other one. The y's cancel, and the x's combine to make the square root of x squared, which is just x. So my final answer ends up being 1 over y minus 1 over x. Now again, I'm not all that concerned about you getting this problem, but I did want to go through and show you what's up with it since it's there. So 76 is asking us to explain why things are equal. You could do that in the form of a formal proof. What I did is I figured out what happens when I square both of these. Well, if you square both of them, it turns out that you get a over b both ways. And if the squares are equal, then the square roots are going to be equal as long as we don't have negative numbers. But since we're dealing with square roots to begin with, you can't have negative numbers. So yeah, since we do get equal squares, then what we have otherwise is equal too. So the ones in the 70s I don't care quite so much about, but the last few problems really are more important. Here they're asking you to evaluate these functions for f of 4, so plug in 4 and see what you get. And again, that's just 4 cubed is 64. Half power means square root, so the square root of 4 is 2. And when you got a negative, you do the reciprocal. That's why number 82 is 1/2. And finally, at the end, you'd have 4 to the 0 power, and anything to the 0 power is 1. So again, that is it for this week. You are going to be back to having an online quiz this week, so you have kind of a clue of where things are going. Next week, we're going to sort of wrap things up, and while you don't have an actual final test, it will be sort of a combination of the stuff that we've done in Chapter 0 that you're going to kind of put together for a little bit longer quiz a week from now. But this week, you got some stuff on exponents, and that's pretty much where we're at. So we'll leave it at that this week. Wish you all well, and we will talk to you one more time a week from now.